What this means for the derivatives to be equal is that f and g have the same slope for any given value of x. So if f was to look something like this, we know that g would always have to have the same slope, giving it the same exact path on our Cartesian plane. So in fact, and this is huge, f is the same shape as g, just shifted vertically. And now on to problem 9. Okay, problem 9. The radius of a right circular cylinder is given by root t plus 2. Alright, we can draw a right circular cylinder, and we know that its radius is root t plus 2. Its height is root t over 2, where t is time in seconds and the dimensions are in inches. Okay, so the height is root t over 2. We also were given that v equals pi r squared, where v is the volume of the can. Alright, in part A, we want to find an equation for the volume v of t of the right circular cylinder as a function of time. And then in part B, we're going to find the rate of change of volume with respect to time, which would be finding v prime of t. So v of t, where v equals pi r squared h, will equal pi. We know r is actually t, the root t plus 2, and then we're going to square it because it's r squared, times h, which is root t over 2. Well, a square root squared is just itself, so we get pi times t plus 2 times root t over 2. We can multiply this out a little bit if we want to, or we can leave it as is. It's kind of up to you. I'm going to leave it as is. But now we want to find v prime of t. Now pi is just a number, so we can leave that off to the side. We do want to pull apart, though, these two factors. So we have u equals t plus 2, and v equals root t over 2. U prime then equals 1, v prime equals 1/4 t to the negative 1/2, which is 1 over 4 root t. We use our product rule and find that v prime of t, we leave the pi out front, and we get root t over 2 plus 1/4 root t times t plus 2. Okay, so distributing the pi again, we get pi root t over 2 plus pi t plus 2 over 4 root t. Which then also equals pi root t over 2 plus pi t over 4 root t plus pi 2 over 4 root t.